so tense.
I have to create a presentation later on also for tomorrow.
Oh yeah, you're not going to recycle any of those.
Recycle, I haven't started any of it, so have to do a quick one later or something. Oi,
Can lah. SEO is easy for you.
Alright, hi guys, we have just came in right on time to the webinar. We are about to get started. Dr. Lau is getting his slides prepared, and we will start in a few minutes time while we wait for the rest to come in. So right now I'm seeing about 26 people already in the webinar, and this webinar today it's really special because for the first time ever, me and Dr. Lau is showing our faces on webinar. All right. So normally we are very screen shy. We don't appear on screen, but for the first time ever, we're going to show ourselves live because we want to actually connect with you guys. So I think that's so important to connect with all of you. So say hi, go and comment on the right side of the screen. You'll see a chat box. Go and say hi, hello, and let us know, me and Dr. Lau, know where you are from. Okay. So I'm going to type out and say hello. I'm broadcasting this live from KL in TTDI. Okay, so let us know where you're from so we'll know the dynamics of the group, where you guys are from. Are you guys from Penang? Are you from KL? Are you from Johor? Or are you from somewhere that we didn't reach out to, but somehow you find a way to come inside this webinar, right? Okay, so we'll wait for a few more minutes for the rest to join in, and we'll start soon. For the rest, for those who just came in the webinar, let us know where you're from, and we'll start real soon. All right, so we are seeing people from. You're watching this live from KL, alias Ga. All right, so we see Cyberjaya, we see KL, we see Penang, we see Subang, Cheras. Anybody here from Ipoh or Malacca? Okay, and while we wait for the rest to come in, we have quite a number of people inside here right now. Okay, so while we wait for the rest to come, I'm going to throw out a poll to ask you, all right? So what is your current role? Let me just publish this on my screen right now. In 3, 2,
Medan
and...
Indonesia. Interesting.
Okay, so you'll be able to see on your screen right now, what is your current role? So this will help us, cater the webinar better to you, all right? So we know who you are, what you're looking for in this webinar. So are you a data scientist already? Or are you looking to be a data scientist, all right? And if you're a business owner, that's the third section for you. And if you're others, right, if you selected others, tell us in the chat section and say, hey, what are you? What do you do currently, and what are you looking to get out from this webinar? All right. What is that one main thing that you want to get out from this webinar, you want to learn, and that we should deliver to you? All right. So type down in the chat section. We'll start in about 8:05, and yeah. So I'm just going to read some of the comments we have here. So we have someone from Medan. Wow, all the way Indonesia. Okay. Ying Hong, hello. We have does being born in Ipoh counts in Ipoh? I guess that counts as Ipoh. That's interesting. All right. Now, before this, I even saw some of you actually registered last minute before the webinar started, like a few minutes before. So I hope that those who registered like a few minutes before the webinar started are in already. We'll start about 8:05. Good to know we have a data scientist in the group here. Okay. Okay, so I'm going to close down the poll soon. I'm still seeing some people answering the poll. So I'm just going to read out the results for you here, okay? Just so you get an idea of the poll results. Let me see. Okay, about 9% of you here in this group here, of all the people here are data scientists. Isn't that interesting? 9%, right? 64% of everyone here in the group is looking to become a data scientist, all right? And we have 9% who run a business. So probably you're business owners, all right? And 26%, 26, answered the other section, all right? So if you have not answered what you are or what you do, let us know in the chat section, okay? We'll start real soon in about a minute. All right. While I look at some of the comments and some of the text that you have dropped in. Again, if you have any questions throughout the webinar, just type in right there. And what we will do is I will personally collect all these answers, keep it down on a notepad somewhere, and then keep it down for you so we can actually ask the questions back to Dr. Lau later on, and when we break for some Q&A sessions. Okay. Hi Jason, how are you? Hope you're doing well. Okay, so we're going to start real soon. We're going to start right now. And just before I pass on the stage here, the online hybrid stage here to Dr. Lau, just want to quickly introduce you to LEAD. So LEAD is an institute for technology and also business. What we do is we train individuals and also corporates, people in data science, web development, and also digital marketing. All right. So the way we do it differently is that the courses that we do are all mostly based on ready skills, job ready skill type of skills, right? So we don't teach from theory books and all those stack of books, but we teach skills that is ready to be used and transferred, right? That can be transferred directly to a working environment, all right? So what you're going to learn in this webinar today can be transferred directly into a working environment itself, all right? So anyway, that sums up this short little introduction about LEAD. You can always visit us at www.thelead.io, and any questions you can always talk to us right here since you're live. All right. So I'm going to pass it over to you, Dr. Lau.
Okay, thank you, Ruben. Good evening, everyone. Thank you for being here. So I'm going to share my screen now and off the camera. So feel free to drop us any questions in the chat section. And let's see. All right. So is everybody able to see and hear me loud and clear? Yep. Okay, let's do it. Probably let's turn this. Yep, to save the bandwidth a little bit. Okay, good evening, everyone, once again. So thank you for making your time to this webinar. Tonight, I'll be walking you through the topic of learn predictive analytics. So here you go, you see the crystal ball, right? So feel free to type in the chat box. Ruben will be there to assist you. So if your question don't get answered because there are too many people at this webinar, you can email me at drlau, DRLAU @thelead.io, and then I'll be able to help you personally later on. Okay, let's get started and learn about predictive analytics. So tonight's agenda is very simple. I'm going to walk you through what is predictive analytics, and then to give you a quick live demo, and also to share with you a little bit about our Data Science 360 certification. So all the materials that I use tonight are actually I extracted from our Data Science 360 certification program, and to make sure that you get a clear idea of how does it work with predictive analytics. So you might have heard of the terms many times about what does it actually do. So don't worry about the slides, taking screenshots or whatever. As long as you stay till the end, you'll get the slides and also the notes. So if you have any notes here, you can scribble it down, not a problem. And then just focus on the webinar. At the end of the day, we'll give you some special offers, and also you'll receive the link at the end. A brief introduction about myself for those of you who are your first time here. I'm Dr. Lau. I'm the Chief Data Scientist at iStream 360. So iStream is a company that we provide B2B enterprise analytics solutions for clients like Johor Corporations, KFC, Pizza Hut, MDEC, etc. I'm also the state advisor of Johor and Selangor State for their smart city and big data initiatives. I won the world champion title for Microsoft Excel expert competition. So what we did in the competition is we have to build analytics solutions for different tasks using Excel functions and VBA macros. Back then, we probably don't focus so much on things like predictive analytics, but we do a lot of forecasting. In the past, they call it forecasting. A lot of things that are called data science today actually is what we call data mining. So that's what I did also when I was in Microsoft E-Research Center. Now, some of you might heard of Magic, especially the folks from Putrajaya, Cyberjaya. Where during my time at Magic, I founded the Academy. So we curate programs that help entrepreneurs, startup entrepreneurs to accelerate their startups. I'm also certified HRDF trainer and also the chairman in MQA to certify Malaysian universities degrees like APU, UTAR, UITM, etc. So I also conduct corporate trainings for FusionX, Intel, OCBC to train the engineers and data scientists. Now, the purpose of sharing all these achievements with you, of course, is not to brag or show off, but it's for me to show you how I eventually learn predictive analytics. So I don't aspire, I don't dream to become a data scientist. Like when you're young in a primary school, teacher asks you about your ambition. Nobody would think of like, oh yes, I want to become a data scientist. Back then we don't even have this field. So data scientist or data science is a concept. So it's a field of study that contains all the different things, and where I utilize my 20 years of experience in different fields: software development, building data products, analyzing data, data mining, etc. Okay, so that's what I want to share with you today, and then to help you to begin your journey to data science as well. So what is predictive analytics? You heard of this term many times. People start to glamorify the entire thing. They sort of tell you like you can predict the future. A lot of things that can be done to predict the future is considered part of the predictive analytics. But seriously, what does it do? So if you look at this chart, is the Gartner Analytics Ascendancy model. So they have this pretty drawn chart that shows you where does predictive analytics actually lie. Whenever we have data, we collect a lot of data, and then we process those data into information. This is what we call descriptive analytics. So you look at reports, you look at statistics information, you look at business intelligence, for example. Those are the stuff that we call descriptive analytics, where we look at information in hindsight. Okay, that is where we actually study what happened. We look at the numbers, we look at the reports, we look at things like, okay, so what happened to the company's financial for the past 3 months? We look at what happened to our HR department, or what happens to our employees in the past 6 months, for example, or what happened to our revenue. If you are coming from a digital marketing background, what happened to the ads performance, to my Google Analytics? So those are everything descriptive analytics. Okay, now once you gather descriptive information and you understand what happened already, the next thing by nature you want to know is, why did it happen? So that's where we actually conduct diagnostic analytics. Diagnostic analytics is sort of like an intermediate. You have to understand why did it happen, or why something did not happen. For example, you put 100 ringgit into a particular ads, and the ROI is very low. Okay, or suddenly you have a lot of staff that they quit from your company. Okay, you need to understand why. In telcos, they suddenly realize that a lot of their users jump from their telco to another telco. So what are the patterns that you can find? Do they suddenly use a lot of their data, or do they suddenly make a lot less phone calls, for example? That's what a lot of telcos company are doing. From there, we take it to the next level, which are predictive analytics. So at this stage, we are working on insights, and in particular, actionable insights. You want to know the insights that allow you or to drive you to make informed or data-driven decisions. So from there, that's where you take predictive analytics to understand what will happen. You have different parameters already. That's why I say predictive analytics is not something that's magical. We have been doing this sort of forecasting, moving average in share markets, in users, in product recommendation for many times. It's just that we haven't really give it a proper name or put it inside a study like data science. And what do we do in predictive analytics stage is we always use machine learning algorithms. Later on, I'll explain to you a little bit about machine learning and also artificial intelligence. Yeah. And once we have done the predictive analytics, that's where we move into foresight. And a lot of the companies, they're actually racing to get this part so that they can optimize their workflow. You can optimize your sales revenue. You can reduce your cost. This is what we do. And this is what we call it prescriptive analytics. At this stage, it's pretty close to what AI is doing already, because you're able to come up with prescriptions. So you're able to prescribe. If A happens, we are going to do this. If B happens, we are going to do that. And this is very close, sidetrack a little bit. This is very close to the concept of what they call a smart contract inside the blockchain as well. Yeah, I don't really talk about blockchain and cryptocurrency, yeah, but remember that these are the criteria that trigger. So once again, a lot of people, when they write if else statements, they think that they are doing AI, but actually they are not. So AI is, you take the results from the machine learning, from predictive analytics. Once you are able to predict the certain outcome at a level, a confidence level, and that is where you are able to come up with prescriptive analytics and optimize your entire workflow. Okay, so this is the flow or the ascendancy models between the value and also the difficulty. Hindsight information descriptive analytics are the easiest to do, and then foresight AI machine learning are the hardest. And of course, the values are much higher because you automate a lot of the processes and retrain your model all the time with more data. So predictive analytics, in a nutshell, is the use of data, algorithms, and also machine learning techniques to identify the likelihood of future outcomes based on the historical data. It's that simple. Yeah, nothing too magic. You're using data, algorithms, and machine learning techniques. You can use a regressions technique. You can use decision trees technique. You have different techniques to identify the likelihood of the future outcomes based on the historical data. Right. So let me give you a couple of examples of projects or startups that have run before. The first one is Hero Boyfriend. Hero Boyfriend is an e-commerce startup. So what we did here is we make money, we monetize based on the habits, the laziness of boyfriends. This is a startup I founded in Australia, in Melbourne. So the back end is an NLP chatbot engine. So my background is in machine learning and NLP, which is natural language processing, not the neuro linguistic programming. Okay. So what we do is, if you are a boyfriend, you sign up for our app. We'll ask you a couple of questions. Hey, what does your girlfriend like? Does she likes yoga? Okay, what food does she likes to eat, or where do you guys always hang out? What sort of activities she likes, etc. So we ask you a couple of questions, and then from there we will do a user profile modeling so that we'll have a very I would say quite complete understanding. Based on the machine learning model, we're able to come up with a profile of your girlfriend, and then from there we make recommendations. So we predict what they like. So this is one type of predictive analytics using natural language processing. In political sense, also they use it to predict, like, if somebody talk bad about something, are they a keyboard warrior? Are they more prone to vote for a certain parties? And in e-commerce sense, we also do a lot of NLP on product reviews as well. So there's a lot of predictive elements here. So once we predict that what your girlfriend likes, so let's say during weekends, we recommend you that, hey, people who fall under the similar profile, they tend to like to watch this movie. So people who like yoga, probably they are going to buy something more soothing. So they love aromatherapy. This is something that is very you can think it laterally, but that's what the data tells you. Usually people who love yoga, they are more likely to buy aromatherapy product, for example lavender. Right. So this is what we predict, and then we give recommendations to the boyfriend so that he knows what gift to buy and then what activities to take their girlfriends or partners or wife to. The only thing that we didn't do well is the number one biggest problem in the world is where to have dinner, where to have lunch. Yeah. Okay. But apart from that, we are still able to make a good recommendation based on the preference, the cuisine preference. So if your girlfriend's like, you tell us that she likes French, and then we recommend you to take her to a couple of different French cuisines, French restaurants, for example. So it's quite easy to do, and it's not that hard to predict. Yeah, especially for masale. Yeah, Guaylo is relatively easier to predict, and they are more likely to tell the truth when they are using chatbot. They trust chatbots more than they trust a human being. Yeah, that's the statistics, lah. And while I was at Microsoft E-Research Center, we used the bird calls and the koalas call to predict their behavior and to predict where they are. So we record their sound recording. And then we use that sound recording to do what they call that signal processing, digital signal processing, DSP. And then from there, we actually analyze those sound wave patterns to identify or to classify them into different types of birds. And then we have to estimate how many birds are there whenever we want to build a new real estate or we want to extend the airport runways. These are the places that you should be going or you shouldn't be going, and etc. And also we look at koalas. So koalas is a very lazy animal. For those of you who have seen them, they sleep about 18 to 20 hours per day. So if you were to you were to put a human there to the zoologist to watch those koalas, you are definitely not going to get anything because you fall asleep before the you fall asleep before the koalas wake up. Okay, so that's a bit of the use case of something that that's non-mainstream when it comes to predictive analytics. Okay. The next thing is a recent project that I worked in Johor Corporation. So these are public data. So we take their annual reports data, and then from there we're able to predict their growth from 2000 to 2017 to estimate their growth, and then to look at the main contributors, profit decrease, and then considering you can look at the text at the bottom, considering the tax and the expenses, profit decrease, etc. So we're able to utilize based on their historical data to make some sort of prediction. So this is another use case of predictive analytics as well in the business world. So the question is, where does predictive analytics lie? Okay, so remember I mentioned to you earlier is that everything there actually fall under the umbrella of AI, right? So AI is the big concept that captures everything. Under AI, you have machine learning, you have deep learning, and you also have neural networks. AI is the application, okay, is the concept. So for example, I'm able to teach the machine how to recognize human speech. All right, I can teach the machine to understand. When I say, "Hey, Siri, what are the temperatures today?" So once I teach the machine enough to understand human language, then we can use this as an application. So for example, if I teach a machine how to detect human sentiments and emotion based on the cameras or the video recordings, I can turn it into AI applications that help me to monitor the class performance or take attendance automatically. So if I'm able to teach the machine how to process credit card application, I can then use that to use it as an AI application to collect more information about credit card applicants. From there, we're able to judge how much credit we are going to give this person, or what are the likelihood or the risk that this person is going to default their credit card, for example. Now, once you understand machine learning, then you might go into deep learning. Deep learning is just another subset of machine learning which focus a lot on large amount of data, which is what we call big data. The reason the term big data comes up because we used to have a lot of data. All right, the storage is never enough. When, let's say, 10-15 years ago, if somebody gives you a thumb drive that's 128 megabyte, you'll be so happy. You're probably like, wow, I'm so glad that you give me a thumb drive of 128 megabyte. But today, even if somebody give you a 128 gigabyte thumb drive, you'll still be like, 128 gigabyte, what can you do? You can't even keep maybe 5 Blu-ray movies, maybe, and then some photos and MP3. That's about it. And lossless music. Yeah. So deep learning is the next step, is the advancement of machine learning. So once we use machine learning and with a lot of big data, okay, a lot of data just with big data, you're able to train the machine to do a lot more things. For example, driverless car. Yeah. And also play chess with computer. You cannot just based on a set of information. You have to keep pumping in a lot more information, and by theoretically speaking, by putting in more data to the model is supposed to be smarter and perform better. And the next one is neural networks. So neural networks is the subset of deep learning, where we train the machines to behave and think like humans. So it's mimicking the way how human brains works, all the neurons, all the bias, all the parameters. We're trying to simulate how the brain works and then use it to help us to make decisions. So eventually, everything that the machine learning, deep learning, neural network that we are trying to do here is to teach the machine to help us to make decisions for us, which is AI. Okay, so once we take that to an application level, they are called AI application. So nothing too magical, right? After I explain to you. Now you may ask me, so what is the machine learning? All right, what is machine learning? Machine learning is not as complicated as you would have imagined. For machine learning, in a broader sense, is that you want to teach the machine, we want to teach the machine to understand the physical world so that eventually the machine can act by itself without human instructions. Give an example. Why do you use chatbot? Because you want the chatbot to behave or act like you when you are not available. You want the chatbot to make money for you when you are sleeping, right? That's why you have a chatbot. And what you teach the machine, you teach the chatbot when somebody asks A, you have to answer this. When somebody asks B, you have to answer that. All right. So you want the machine to act by itself without any human intervention. You don't want any human instructions to use the machine. Now, broadly speaking, there are two types of machine learning, which is supervised and unsupervised. Supervised learning, it helps to predict values. Given a data set, the machine will learn the model from the known instances from the data set. The more the data, the better the model will perform on unknown examples. Now, the other one is unsupervised learning. Unsupervised learning is to help you to understand your data set better. It helps you to group and classify or cluster those items that are similar. So, for example, if you look at this simple chart, right, you might consider the 8 blue circles, as two groups of people who bought things from your e-commerce store. The one on your bottom left is somebody who has similar X1 and X2, and the one on your top right corner is another group of people who has X1, similar X1 as X2. So now you classify them into two groups. You may use them to do different things, right? You may say that you still don't know who are group 1 and group 2, but one thing that you can know is the group 1 and group 2, they are different, and group 1, they behave similarly, and then the people in group 2, they behave similarly. So you can, based on their behavior, based on their patterns, their clustering and unsupervised learning, we talk a lot on patterns. Based on those patterns, we can do something. You want to do targeted ads, for example, you want to give them some special offers, that's also can. Yeah, that's where all those e-commerce stores, especially the big one like Alibaba, Taobao, they're using similar techniques to do customer profiling and then recommend product recommendation and preference. Right. When it comes to supervised learning, yeah, there are few types of supervised learning algorithms there for machine learning. So the first one is decision tree. Right? Decision tree is also the one that I'll be showing later on using the Titanic data set. All right. So decision tree is you put in a training set, right? A lot of data, a set of data. The algorithm will actually picks up like where are the splitting points. So you look at the first one, isoelectric point. So if it's less than 10.06, what will it do? If it's greater than 10.06, and then what will it do? And then from there, they further split into different stuff. Okay, so this is a decision tree. So we make decisions based on different criteria or different node. And once you reach the end node, right, and then you will say, okay, all right, the machine will decide this is a medium activity or low activity or high activity. Yeah, this is decision trees. We can also use regressions in our predictive analytics. Regression analysis is a set of statistical processes for estimating the relationships among variables. So you want to model the relationship between two variables. And it includes many techniques for model and analyzing several variables. It's not just two, it can be multiple as well. And we always use regressions for predictions and also forecasting. In layman's terms, determine y given x or a series of x, right? A couple of x, x1, x2, and then we'll tell you the value of y. The most common regressions that you have seen in the data science task is linear regressions and logistic regression. Linear regressions usually is for us to forecast the impact and also predict the future values. And also we do performance rating and also risk assessment. Now, logistic regression is something that's more interesting. It will always give you a score that is between 0 and 1, which is the likelihood or the probability. We usually use this in the classification problems, for example, handwriting recognition, mental state stability prediction based on their speech. We also use that to determine whether a mail that is coming that came in, whether it's a spam mail or not, based on the features or the different types of words inside. So in sentiment analysis and also product reviews, we use that a lot because we can turn text information into numbers, and then from there we can use logistic regression. You can look at the chart here, right? Yeah, it's actually go from 0 to 1. Okay. Now, for unsupervised learning, we usually use this technique called clustering. It's very, very popular. Of course, there are others more advanced one when it comes to deep learning, but unsupervised learning, we focus a lot on clustering, especially at the machine learning level. Clustering analysis or cluster analysis is to group similar items together for, like I mentioned earlier, targeted marketing analysis for user behaviors, anything that's related to patterns. Another example that I can give you is hashtag. So usually you look at people's, they tag image with different hashtags, right? So eventually we're able to come up with a clustering model to say if you use a hashtag, let's say YOLO, YOLO, this hashtag always get tagged together with other tags like, okay, you only live once, and yada yada yada. So those hashtags together, they form a clusters because they always appear together and use it on certain types of images. So you can conclude that, right, this sort of image, they are similar because they have they display or they have a patterns of hashtag, they are similar. So this is what clustering analysis is doing. Okay, so long story short, machine learning is for us to learn how to make decisions, okay, to teach the machine to learn how to make decisions with the data given to it. It gets progressively better when it's given more training data, right? So I've given you a broad introduction to predictive analytics, okay, including the different stages of the Gartner ascendancy model. Before we go into live demo, okay, you have any questions?
Okay, so far, I think there's no questions. They are still listening to what you have to present. Okay.
Cool.
So if there are no questions, probably can just take a cup of water or something and then just continue with the presentation, I guess. All right. Okay, guys, if you have any questions, let us know. Let us know in the chat section on the right. I'll take down all these questions and make sure they get answered by the end of the webinar. Okay. So
yeah. So this is a very interactive session. Yeah, we try to bring the classroom. For those of you know me, you know my style, right? Me and myself and Ruben, we try to bring the classroom style here. So feel free to ask us any questions that you have. Yeah. All right.
Okay. Let's continue then.
Yep. Okay. So the sinking of Titanic is probably one of the most infamous shipwrecks in the history. Yeah. So on 1912, April 15, during the maiden voyage, the Titanic sank after colliding with an iceberg. So I think 1,005, the entire Titanic has about 2,000 plus 2,002 passengers, and then 1,005 of it, they were killed. So this tragedy really shocked the community. So it leads to a better future safety regulation for ships. All right. So one of the reasons that the shipwreck led to such a loss of lives was that there are not enough lifeboats for the passengers and crew. So a bit of background, right? Yeah, and there's some sort of luck elements involved. But when we look at the data, right? When we look at the data, we found that actually there are some patterns, and those patterns are not really that counterintuitive. But there's a lot of things that you can take a sneak peek and sort of like it makes you wonder. Okay, it makes you think. So I'll quickly walk you through some of the analysis that we use in the class, and then how to use machine learning decision tree to predict what type of passengers are more likely to survive. Okay, and we will use machine learning to predict their survival rate. So let's look at the data set. Don't worry about the data set and the slides and also the source code, all right? We'll send it to you after the class. So this is the Titanic.csv. We get it from Kaggle. Kaggle is a very popular data scientist community where we go there to look for discussions, we look for ideas, we interact with other data scientists internationally, and also what we do, we get a lot of data. Yeah, we get a lot of open source data, anonymized, high quality data, and we work on problems together collaboratively. So there are also forums that we can do. Okay, so let's look at the Titanic data set that we're using here. Is now you have passenger ID. So this is just 1 to 800, 890. And then you have survive. It's a binary data, meaning 0 and 1. So 0 is did not survive, 1 is survived. So in other words, 0 means dead and 1 means alive. Now, P class is the passenger class. So passenger class is determined by the type of tickets that they purchase. And then you have sex, which is their gender. You have their age. You have SIBSP is siblings and spouse. And PRCH is parents and children. Ticket is the ticket number. Fare is the amount or the price of the ticket that they pay. And then you have the cabin that they are at. And then embark is the port where they embark. Usually when we tackle a task like this, right, we'll do a lot of data cleansing. We'll go through the entire data set. So later on you'll get this file, so you'll see all those things, all those data and stuff there. There are other also, but we make some notes here. Let me see if I miss any. Okay, yeah. So some travel with very close friends in neighbor in the village, but the definition do not support such relation. So remember that was quite a while ago, right? We're lucky to have this information here or this data here. Sorry, Jack and Rose are not in there. Sorry if I blown your dream. All right, so so let's look at the data in terms of the cleanliness and the complete thing. Okay, now we have quite a complete number of names. I think male and female is okay. So let's look at age. Age seems like there are a lot of blank numbers here. All right, there are a lot of empty numbers here. Okay, so this is something that we need to fix it. Siblings and spouse, yes. Parents and children, they look okay. Then ticket is the field that is it doesn't make sense when we investigate it. Yeah, so you look at this number of ticket. The ticket number, not number of ticket. The ticket number, because they bought it at different place. So like today, you buy your ticket from different agent. So you probably don't know which agent assign what are the code that they use. So in predictive analytics sense, this column or this data, this attribute or this feature is not indicative, or the predictive power is low. Yeah. So we probably want to discard this column later on. And then you have fare. Yeah, you have the ticket price, and you have cabin. So cabin, there are too many missing data here already. So we probably we're not going to use this column as well. And this is number. This is a Mac software that is similar to Microsoft Excel. So yeah, you can use it. You can also sort and filter the things. So for example, you can sort. I want to sort based on age. Yeah. Right, so you can look at the youngest passenger is 0.42, so it's 0.42 year old. Yeah, so it's about 5 months. So baby, yeah, and also baby travel with their parents lah. Yeah, baby. Most of them, the baby travel with their parents, right? Yeah. Okay, some with parents, some with just father or mother. Then you have 1 year old, 2 year old, and stuff. Okay, so this is just to give you some basic information about the data set. So, the tools that we are using here is called, the programming language is called Python. All right, let me give you a quick introduction about Python. The entire package that I've installed is called Anaconda. This is the same package that we use during our data science certification. Now, Anaconda is a package, it's a software package, and Python is an open source language. So everything on top, yeah, if you look at the bottom, Python is the language that powers everything. And then you have IPython, which is the interactive Python that I'm using, or the Jupyter notebook. We have also NumPy, Matplotlib, the plotting library, and we also have Pandas, the number libraries, and also SciPy and scikit-learn. I think I skimmed through just now. Some people asked about image processing and stuff. We have OpenCV as an image processing library. We have also scikit-image and also scikit-learn. These are more for machine learning stuff. And then, yeah, if you take it further, you have a lot of stuff. You have PyTorch, you have Keras, you have TensorFlow. Those are for deep learnings. And the good news is they are all free. They are free and open source. So that's how data scientist community grow very fast. Yeah, because you don't have to pay for the expensive licenses. I'm not saying that those expensive software, the one that you pay are not good or not, but basically that's what we do. Yeah. Majority of the data scientists we use either Python or R. So I'll quickly go through the code. So if you have any questions, just voice out, okay, or type in the chat. Ruben will notify me later. And we import Python, pandas as PD, and then NumPy, and then Matplotlib, and also Seaborn. Seaborn is a package that we use to draw chart. So first thing first, I read the CSV file, Titanic train.csv, using pandas into our data frame called DF. Okay. Now, first thing I want to do is, like I said, I want to explore data. So we need to gain big picture and broad understanding of the data set just by looking at numbers. We don't look at non-numerical data first. We look at numbers. Numbers are essentially what we are going to process. Even, remember this, no matter what sort of predictive analytics that you're doing text, you're doing image, you're doing audio, takesa. It doesn't matter. Every predictive analytics that you do are based on numbers. I have to turn those audio into signals, right? Ruben is a musician, so he knows this better. Yeah, digital signal processing. You have to convert those signals into numbers, into values, into peak values. Then only we can process it. If you are doing image processing, you have to calculate different types of features. You can do object detection, you can do object counting, you can do pixel counting. Let's say this image, majority of this image, is it a particular color, or what does it tell us? All right. And of course, textual information. We have to convert those text into numbers before we can calculate how similar is these two documents, whether let's say in Google I put in a keyword, how this keyword is related to other documents. They're all numbers behind. Yeah, nothing fancy. So first thing first, I'm using Seaborn, okay, import Seaborn as SNS. I'm using it to draw a heat map for me. Now, don't worry about these settings. You'll get this source code. So setting basically is I set up the figure size, or I set up the type or the color so that you can look at them easily. So this is a heat map that they'll give you the correlation of all the different features in the data set. All right, understand? So for example, we can look at passenger. So the diagonal line is this part. Okay, so this is the diagonal line, and they are always mapped to their its own. So fair and fair. A correlation chart is for you to identify the correlation between two variables. So fare and passenger class, they're negative correlated, meaning that the lower the class, the higher the class, okay, you are 1, and then your fare is very expensive. But if you're class 3, your fare is actually very cheap. Yeah. And then let's look at their survival rate. Okay, so survival rate actually is quite highly correlated with passenger class, for example. Okay, then the negative and the positive is to point towards the direction, but what is more important is the number itself. Yeah, they are not to say they are not important, but we care about the level of correlation first. Then only we care about the direction, polarity. So some of the information here is, or some of the features here, they are very weakly correlated. So for example, passenger class and siblings and spouse. Yeah, not much lah. Tidak berkaitan, tidak banyak berkaitan. And then you look at passenger class and also their fare. Yeah, okay. So they are closely related. So this is the first thing I'm going to teach you. Very useful. So later on, when you, after the webinar, you want to practice or you want to implement the data set, your own data set, right? You can just take this code, replace the Titanic train.csv with the file that you want to do it, and you can use the same command. So it's a very good template to start with. So you can call a heat map and then try to understand the correlation between different variables there. Now, after we have understand the correlations of those variables, the next thing we want to do is we want to look into summary statistics of those numerical field. So what we'll do, we call df.describe. Describe is a features of data frame came from pandas. It allowed us to quickly give you a snapshot of what the data sets and numbers are about. So for example, we look at survive, passenger ID and survive, we do a count. So we have 891, this number tally. So 891, 891, 891. And suddenly you look at 714. So it's different from 891. All of the columns, they have 891 except age. So we know that age has 177 missing values. Okay, 891 minus 714, which is here. And let's look at arithmetic mean. Arithmetic mean usually doesn't mean much. It's just to give you a feel of the average number, of what are the average number. So you look at the mean. So the mean age is 29.69, 27. And what is interesting is the survive rate. So the mean of the survive, meaning that this about only 38% of people survived the Titanic disaster. STD is standard deviation, mean and max, and then you look at the percentile. So you can look at how much the numbers varies. The interesting part is if you look at fare, right? Some people actually, they're willing to pay up to $512 just for one particular ticket. This is a ripoff, man. But some people, they don't even have to pay. Probably they got a lucky draw or they got some free tickets. So yeah. And just by calling the describe command, you don't have to do anything. I wouldn't say there's coding needed even, right? You just have to put in the CSV file, run this template, and then you get all this information and you can explain it already. And yeah, that's about it. There's nothing else that's interesting. Like for example, age, you know that the minimum age is 0.42, the oldest is 80. Yeah, majority 50, 75 percentile. Most of the people are around 28 to 40 years old. Okay, so we can look. We can also look that about 35% passengers survived the tragedy. And looking at the percentiles of P class, you can see that more than 50% of passengers actually belongs to class 3, right? Yeah, you look at the P class here. The 25% is 2. Okay, so below 25% is either 1 or 2, and anything above that is 3, 3, 3. Yeah, so meaning there are a lot of people who are third class ticket. Age distribution seems to be in line with expectation. The fare seems to have value of 0, indicating some free tickets or data errors. And on the other extreme, 512 looks like a possible outlier or error. Okay, yeah, if you have any question, just type in the chat box. Okay, now next thing is we also want to check for outliers in our categorical data to make sure that they're all correct. So I can call the unique command. Unique command gives us the unique value of a particular column. So I call it on the I use it on the sex and also the embark. So we know that in the sex column we have only male and female, which is good. You don't have any funny values. Now in the embark column, we actually have SCQ and also NAN, meaning that they are missing values or they enter not a number. So there are some dirty data here, but so far sex is quite okay. Yeah. And we can do a calculation again by using the survive. So people who have survived versus the total number of passengers in this Titanic. So yeah, we get the same number, 38%, which is similar to this one, which is the same as this one. Yeah. Okay, so next thing is we're going to use some non-numerical analysis for our categorical variable. We have already done our numerical analysis, meaning that these are standard statistical method. Okay, yeah. And again, these are some commands to draw chart and also to add labels and also to set the type of charts. So usually when we draw charts, right, categorical variables, a lot of people, they don't really understand the difference between bar chart, pie chart, column chart, line chart. All right, so give you a brief introduction, or you can watch our data crunch episode 2. Yeah, there's a data storytelling session that I actually talk about how to use the chart effectively. Pie chart is good to show composition. If you have something that's composition and the sum is 100%, that's number one. Number two is the portion has to be significantly different. So if they are all close, like 11, 10, 10, 11, 12%, and they're all very close, you can't really see which pie is which slice of pie is exceptionally huge or small, then it's probably not a good pie chart. And then if when it comes to categorical data, we want to compare categorical data, is ideally we should use things like bar chart. Or this is column chart, yeah, meaning that is on column. Bar chart is horizontal bar chart. We usually use column chart when you have significance and then you have things to compare like this, that's fine. But when you have too many categories, let's say you have top 10 companies in the region, or you want to have top 10 sales performance or salesperson performance, then it's better to use bar chart because you can easily see the difference and also visualize the scale, how much they're different. Okay, so on your left hand side is the passengers by P class. So you have passenger class 1, class 2, and class 3. So majority of them, the green color one, they are all coming from class 3. And then half of it are actually class 1 and class 2. And probability of survival by class, this is the part where I say, hey, this is something that is weird. Yeah, it's very intuitive where rich people, they have higher rate of survival. Yeah, but we won't go into details about discussing the why here. Yeah, that's the exercise that we do in class. And there are a lot of discussion online. But things like probability of survival, you look at the first one, rich people, class 1, their probability of survival is over 60%. It's close to 65% even, right? 62% here. And then class 2 is also not too bad. At least you got 44, 48%. Class 3 is pretty bad. Yeah, it's only like 25%. And we can also use another method. So if you think that it's very hard to visualize this way, we can tabulate them and then we do a cross tab. And this is also what we call a stack bar. Now, using a stack bar is easier. So we basically cross tabulating them with male, female, and also their passenger class. Now, we further analyze the data is we found that female of the first class actually has almost the highest survival rate. You look at the blue color portion, is those people who have survived. Yeah, so this is the part where first class female survive, and then first class male, I think they don't want to live already lah. Same like third class male, they're like, okay, I'm tired of living. Yeah, but there's actually a lot of stories behind that we can discover. And I remember during the class we found that, okay, these are the people actually who happens to be married guy also, cause of people like Jack. Come on, Jason. Yeah, okay. So third class female, you shouldn't call them third class. I mean, passenger from third class, like passenger from class 3 with ticket class, third class ticket female, and male. They have quite an average distributions of survival rate. And then even you got the second class ticket, also your survival rate is still high. Yeah. Okay, if you look at it, on average, male don't survive lah. Yeah. So often we have missing and incomplete data in our data set. So you try your best to overcome it, because there are some cases like cabin, embark, and ticket. Those information does not make sense to the analysis. So as a data scientist, you should know when we do data collection, data gathering, you should sample all the data that you can. Right, because you don't want to get summarized data or aggregated data. You should always strive to get raw data. But after that, what you can do is you can then discard some of the data during your modeling stage. Okay, so here comes the interesting part. how are we going to construct a predictive analytics model using a decision tree? So walk with me slowly. Yeah. So first thing is, all right, let's clean the data first. Okay, so this is the part where I calculate the mean age. So because there are some missing age entries there, so we have to use average numbers. So if there are too many missing data, we usually discard the column. But for numbers data, we try to fill in the numbers with average data so that we try to get a more proper distribution. If it does not affect your calculation or your modeling too much. Yeah, that's what I meant. All right. Okay, so let's rerun the thing again. Describe. Draw the chart. Okay, clean the data. So here, once again, we import pandas and numpy, but we also import the tree from scikit-learn. sklearn is scikit-learn. Okay. Now, when we are constructing our training data, so a brief introduction about what is training data and testing data. In data science, usually you don't use your entire data set to train your model. Yeah, we usually split the data into 7-3 or 6-4, depending on your situation. So we have 30% of testing data, and 70% we use it to do training. And then later on, we can swap them. We can mix around, and then we can randomly pick another 60-40 or 70-30 to train the model again. Yeah, all right. So, before we proceed, I see some questions already. So, Ruben, is there any questions any one or two questions I can answer straight away? Probably just take one question. Yeah.
Okay, so probably we can answer one of the questions that we got earlier. So let me just see. All right, let's answer Zulfazli's question number 2 and say, who normally consumes the data scientist findings? In other words, who is the main audience of all these findings?
Yeah, that's a good question. So usually who in data science, especially when we talk about corporate projects, I use corporate projects since most of you are coming from the what do you call that? A corporate or working background, meaning that you guys have some sort of business experience, right? From the survey that we know. So your main audience is usually your problem owner, because that is the things that interest them the most. Let's say we work in the government agencies, we work with those are the stakeholders, the ministers or the board of directors. They are interested in the finding, so they want to know that how these numbers, how this data and your predictive model can help me to make better decisions. This is Titanic. We picked Titanic because number one is very easy to understand, right? We have another example that we use in the class is the HR data set. So we go into the company, we perform HR analytics with the client. So HR department will be the problem owner, and they will be our primary audience. So when we talk to them, right, we have to use their language. We cannot say, oh, last month your resignation rate is X and Y. Yeah, they have to be like, we have to use the right words. Oh, your attrition rate, your education spending, your ROI in whatever. Yeah, so that would be the problem owner. I would say problem owner are usually the one who consume data scientist findings, because they have to use the findings to help them to elevate and solve their pain points. Good question. I'll probably take Ying Hong's question as well, since I've seen it. For further data explorations, are we going to focus only on highly correlated fields? No, short answer, no. Because why? Highly correlated fields, this information only tells you how much they are correlated. So I can say, for every 1 kilos that Dr. Lau put on weight, and there are another 10 trees that die. But the thing is, this information is It's not true. They're highly correlated. So it doesn't mean that if I put on 10 kilos, I'm going to kill 100 trees. A lot of people, they lie. They try to lie using correlation. They're trying to use this sort of information to lie to you. I'm not going to name who, but you can find that a lot, especially in those public research papers, statistics thing. Yeah. So you have to be very careful when you look at correlations, because you are the one that work with the data set long enough so that you know that, oh, okay, this data set has a particular thing. That's why I intentionally keep passenger ID here. Passenger ID has nothing to do with any single field. Okay, passenger ID will not affect the fare, will not affect your age. But when you have big enough data, okay, you actually can see some significance. When your data is too huge, all the statistical significant tests will fail you. Yeah, because when it's big enough, can find significance. Like you work on e-commerce data, you go to China, you take their data set. Any data set can give you significance. Yeah. Okay. So Jason and Ruben, okay, is highly correlated with lung cancer. All right. Yeah. You're right. So okay, so see, the guys are giving you some examples, the smoking guys. Yeah. So remember, correlation does not equal causal. All right. I'll type this now. Correlation does not equal causal. Just remember this. And why am I teaching you correlation here? Because it's the very first step and very visual way for you to understand the relationship between numbers. That's all. Yeah, that's all. It gives you some sort of earlier indicators. Okay, that. All right, let's continue. Okay, oops, mouse. So now we are going to construct our training data array. Okay, let's continue with the topic, training set and then testing set. So the training data, we're allowed to pick different columns. So here I'm going to pick the age and the sex, which is the gender. Now I'm also saying here is this is a Python shorthand. 1 if S is equal to male, and else 0 for S in df.sex. Meaning that if it's male, we give it a 1. Otherwise, you give it a 0. So female is 0. And then training labels. So for supervised training, supervised learning, we are using decision tree, which is a supervised learning method. Yeah. We need to give a label. Only unsupervised learning, you don't have to give it a label. Okay. What is the label that we're going to use? Labels is a technical term. In short, it means the target. It means something that you want to predict. What I want to predict now, I want to predict this person is going to survive or not. I'm not going to predict what is the ticket price that he's going to pay. I'm not going to predict which class he's at. I'm going to predict, given the age and the sex, I want to predict this particular person will survive in the Titanic disaster or not. Okay, this is how I'm going to build my decision tree. Okay, so after you have done that, okay, we can use the classifier. A classifier is what we are using as a decision tree. So tree.decision tree classifier. We initialize a decision tree and then we call fit. So whenever we are trying to train a model, we call it fitting. Remember, it's all mathematics. Yeah, this is a curve that we have a lot of data points and we try to find out which curve it fits them well. So we are trying to fit our training data into our classifier using our train labels. You just have to understand this, and later on when you use this, you don't have to change the code. You just have to make sure that you pick the right training data, and they have to be number, right? You look at this. If I change it, if I don't change it from male to 1 and 0 to female, I will fail. The machine, it will give you error. All right. So after that, I'm going to build my tree. So okay, it tells you that this is a decision classifier. There are a lot of parameters that we can adjust, but we're not going through later today. Yeah. Okay. Then we're going to print a score to see how good is the performance. So the performance of our decision tree is 81.93%, 0.8193. You times 100 is 81.93%. Okay, up to this stage, you are clear. Is there any rule of thumb to choose the training data set? No, it's a 70-30%. So usually we pick 70. That's why you realize that the data set that I pick here has about 890 records, 890 entries. The other one, the testing set, you have another, I think close to another seven. No. Another, I forgot the actual numbers. Let me have a look. Titanic test CSV. Yeah, we have another 400 plus here. So this is the entire data set, but I already split it into training set and testing set. So I have 890 close to 900 there, and then I have another 420 here. Usually we do it random split, and what we want to do is why particularly 730 and 60/40. This we don't want to have too many testing sets. So the performance of your model, right, is as good as your training data. So you definitely want to have a large portion of training data. No, I'm not using all the columns. Hey, those are good questions. Keep it coming. Yeah. So 70/30, 60/40 is just an arbitrary number. Like we plug the number, we patate the number. But takkan you are going to use a 40% testing set to validate a 60%, 40% training set to validate a 60% testing set, right? Yeah. So definitely we are using more data to train and then a smaller portion of the data to test, so that later on, which is the next main thing that I'm going to talk about, is we're going to predict your survival rate, whether you will survive or not. You are in a Titanic. So Jason, give me your age, please. Randomly pick somebody. So let's say I know Jason is 20-year-old. Okay. Sorry for the screen thingy. And Jason is 20-year-old, and then he's a male. 20. Hey, you're 20 years old already. Okay. So array, it gives the answer is 0. Sorry, if you are in the Titanic disaster, you won't be survived. I'm sorry, Jason. But similarly, if you look at the 20-year-old lady, I'm sure the result is also 1. So let's look at 30 years old. Yeah, 30-year-old lady in the Titanic disasters, the result will be 1. So later on, you will get this file. You can play around with it. Okay, I'll give you the file data set. All you have to do is to download Anaconda, install it, and then run it. Yeah, it comes with all the Python and then pandas and stuff, so don't worry. You can play around with the training data with different columns and then different inputs as well. So when you use your own data, just make sure that all of them are converted into numbers, and then you can use that to do some sort of machine learning to play around with it. What is the baseline percentage for model accuracy that could convince your audience? That's a very good question. Well, you guys are professional, man. It depends on the context. So let's say in the context of Titanic, 81, 82% on, let's say we talk about the competition, usually considered quite good. Yeah. No hard number. I give you an example. If you're talking about medicine, medical field, right? 70-80% is horrible. You need to aim for 99.99999%. That is considered a good model, because every single mistake that you make there, you're likely to cause somebody to die. Let's say I come up with a cancer prediction model, or colon to be more exact, colon cancer prediction model, and my prediction is 20%, 80% correct. That means that for every 100 people that I treat, 20 people is going to be wrong, and these poor fellas are going to have their colon cut off because of my prediction model. So you must make sure that you have a very high 99.99999%. That is considered a good baseline. Yeah. Then of course, if you are talking about customer service, customers experience, then I would say 80-85% sentiment analysis, that's considered very good. Yeah, even on academic competitions, research field, because it's very hard to understand human language at this stage. We might have large data set with many columns. How are we going to decide the columns used for the training data set? Okay, so you will need something called feature engineering to help you to pick the right columns. At this particular exercise, if you have, let's say, 5 to 10 columns, you usually can play around with it, mix and match, and then using your own not to say your gut feelings, but using some heuristic information. So those things that you already have. So for example, I wouldn't think that the number of kids or your siblings and spouse is going to do anything in your survival rate. But who knows? Because you have a spouse, so that you're more likely to risk your life to let your spouse survive than then you risk dying. Okay, so for Ying Hong's question, I would say it depends. Yeah, but we have specific ways for you to do features engineering to find out what are the principal components, for example, that affects the performance. So we can use it to zoom down and reduce the number of columns. Okay, so let's continue. Right. So and these are the tools that we'll cover during the DS360 program as well. So yeah, thanks for your time. And I think we run slightly over time already. So for those of you who would like to become a data scientist, and then you would like to join us and to be part of us, whether you want to start a fresh career in data science, or you want to switch your career path from an analyst, actuarial science, finance to a more exciting data-oriented career. I hate to say this, but people keep calling us, the sexiest job in 21st century. Don't really like the title. I mean the description, but I do think that data science is a very exciting journey, so that it allows us to work on different projects, to meet a lot of new people and solve tricky problem every day using data. And it's very, very challenging job. Yeah. So one of my students, Rebecca, she's from the previous training. She's a consultant with programming background, one of the rare girls who can program. And through the data science class, she picks up all the data processing analysis skills. And now she already joined the newly formed data science team in the consulting firm. I think she's from NMG that she worked. Another one is Suhail. Suhail and his brother were my student. So he has a background in economics, and then he would like to become a data scientist. So he took some online courses, those MOOC, Coursera, Udemy. He did build some basics, but he found that it's very hard to proceed. So he ended up attended my course and then picked up the data science and analytical skills for economics. So then his brother is currently working in Faith as a junior data scientist as well. Yeah, associate data scientist. So everybody can learn data science. And I think everybody should learn data science and start to make impact to the world and see the world differently. Although Suhail comes from a non-technical background, but he's very committed and he dedicates time to learn and work on the practical. So he's confident and he's ready to start he already finished his internship in the data analytics company. Yeah. So thanks for being here. Thank you for your time. I can't really cover everything in predictive analytics, right? And then I'll try to answer as many questions as I can later. Now, even if we have 1 or 2 days, we just can't cover everything. So if you feel overwhelmed, I've barely only scratched the surface. So you really need time to learn, practice, and guidance to work on the practicals to get there. Yeah. So after tonight webinar, I really hope that you guys will continue your journey. Yeah, most of you will, but you have two options. Number one, you keep learning on your own. Yeah, spend thousands of hours, try to look for free tutorials, spending hundreds and thousands of, you spend a lot of hours, countless hours, but you get very frustrated because you have to figure out some of the coding on your own without any support. So after 3 to 5 years of doing this, you will become a data scientist eventually. So look at me as an example, right? You know me as a chief data scientist, you know me as Dr. Lau, but a lot of effort that we have put into the studies, the project, and the research in the past 10, 15, 20 years. We really put in a lot of effort. Or if you want to fast track, right, I would say that you don't have to waste time making unnecessary mistakes on your own. People do make mistakes, we make mistakes, but I hope that you don't make unnecessary and silly mistake on your own, but learn from a system that we have. I have personally learned and developed, and I've trained a lot of students, and also I'm still been there, I've done that, and I'm still practicing it. So that's the key thing. A lot of people, they think that data science is hard to learn. Yeah. I'm not a motivational speaker, so I'm not going to give you any chicken soup kind of material like, you have to work hard, yeah, follow your passion. No, that's not a scientist would say. You basically, if you want to succeed in learning some new skills or new knowledge, like enter a field like data science, you need a learning plan. So most people, they don't have a plan and they don't know the right approach, meaning that you don't know the right directions. And of course, you are not committed to the plan. That's the worst thing. So we're currently launching a new program called the Data Science 360 program. So this program is a coaching mentorship program that helps you. You don't have to figure out things on your own anymore. Yeah, you don't have to spend years like what we did to build up the basics. You learn the fundamentals, but you don't have to do this alone. You no more try and error, no more trying to figure out what are the right tools. You look at you Google data science. There are plenty of blog posts, plenty of tools that you can pick from, but you don't have to do that anymore. Yeah, you can follow a system, a proven system, and as long as you're committed, you can continue your data science journey pleasantly. And this is a professional certification, so it's going to cost you money. And considering what I have taught you so far in the webinar, I think it worth the money, right? Yeah. So many students like the program because number one, this is a certification program, so you get a cert in the end. We have 4 days of classes in August and September. So 2 weeks later, 25th, 26th August, and 1 and 2nd September. 1st and 2nd September, 9 to 5 at PJs. And on top of that, we'll give you 8 hours of online trainings materials that you can learn at your own time. That's to tamba on top of the 32 hours that I train you. So with 4 times 8 hours is 32 hours plus another 8 hours learn at your own time, your own flexibility. Yeah, online trainings. And this particular program will be trained and mentored by myself personally. Yeah, so I'll be there for all 4 days to guide you through. So what will you get out of this program? You definitely get a kickstart. All right. We'll show you the roadmap that walks you through the data science journey. And you'll get an upgrade to your current skill sets to prepare yourself for the data technology era. It doesn't matter what backgrounds that you're coming from. All right. You're coming from a finance background, you're coming from an insurance or actuarial science background. It doesn't matter. But we'll upgrade your current skill sets with data science so that it future-proof your career. And most importantly, you'll learn how to self-learn after the program. Yeah, I'm not here to give you a magic pill, but after this, you'll learn the skills how to continue to learn after the program, and you'll build a portfolio, a data scientist portfolio that showcase your ability. You can use this to look for jobs. You can become a freelancer if you want to, or you can continue to become a data scientist in your particular field. Yeah, so I will make sure that you build at least a portfolio projects that you can showcase at your before. So what will you learn? You'll learn job-ready programming skills for data science. A lot of people, they will ask me like, hey, Dr. Lau, do I need to have programming background? Do I need to have technical knowledge? No, we'll cover Python. I've shown you Python just now, right? It's not that hard. There are some syntax involved. It's just like learning a new language, but it's not that hard as long as you follow through. And most importantly, we'll teach you all the skill sets that you need: collect, extract, query, clean, aggregate data, perform statistical exploratory analysis that you have seen just now, and also analyze structured and unstructured data. Most of the courses out there, they teach you how to analyze structured data, rows and columns, transactional data. But I will also teach you all the techniques that we analyze text information. So how to compare similarity of two articles, how to extract information from Facebook and Twitters and do sentiment analysis. These are the things that we'll cover in the program. And also how to create visualizations and dashboards. Yeah, using like Seaborn and some of the tools that we will teach during the class. But most importantly is you learn how to use the charts and visualization device effectively to tell a story. Okay, and I'll teach you how to think like a data scientist by showing you how to frame a business question into data science problem. So this is a core skill. Yeah, you need to ask the right questions and formulate them into data scientist problem. And how do you build machine learning models and implement algorithms for predictive analytics? So decision tree is one of the common one that we use, right? The one that I teach you just now. But we will also cover things like clustering, logistic regressions, linear regressions, and also forecasting using ARIMA. So those are stuff that we'll cover, and also teach you how to do communicate your findings and then deliver a presentation effectively, even to a non-layman person. So this is a sneak peek of what we are going to teach you. Awesome framework. So we'll cover the end-to-end process of obtaining, scrubbing, exploring, modeling, and interpreting your data. It's just a recap of what I have been teaching you so far, right? So how do you obtain your data? You gather your data, all right, a CSV file, JSON file, web API, Excel file. How do you process them into something that you can handle them? Not everything can be processed by a data frame, right? But I want to make sure that you know how to process them, and then how to clean your data. The one that I show you is just a very elementary level, but you need to learn how to fix up the dirty data so that you can explore and model them, yeah, using different modeling algorithms, machine learning stuff, and then interpret your data eventually. Okay, so let's take a quick look at the course structures. We have a couple of modules. We have total 6 modules. The first module is we walk you through the data scientist workflow, give you a refreshers in Python, and also all the different components in Python. I'll be there to walk you, to hold your hands, to walk through the entire setup process, make sure that you get up to speed, and also the ETL process and data cleansing. How do you gather the data and clean the data? That's for module 1. After we have done module 1, I'll teach you databases. Now, again, this is the key uniqueness of this program. Not only we teach you relational data, we teach you NoSQL. Yeah, we teach you how to design a database, how to work with different data sources, and how do you write SQL script, how do you use SQL statements to perform, create data, retrieve data, update and delete data. Day 3, we're focusing on MongoDB. For those of you who have never heard of MongoDB, it's a document-based unstructured database. So it's very good at processing unstructured data. Yeah, and this is where we learn things like natural processing, natural language processing, NLP, and collecting data from Facebook and Twitter, mining information, and analyzing sentiment. So this is where you learn how to gather news articles, for example, and then process them. Now, module 4, supervised, unsupervised learning. Module 4 focus a lot on machine learning. We spend a good whole module to talk about different things so that you will also learn the AI applications and neural network basics. Yeah, for you to prepare yourself in the future, if you need to learn deep learning or neural network, you know how to do and you know what to do. Yeah, and we'll teach you how to evaluate a machine learning model, like what we show you just now, and some of the good questions that you asked. And module 5, visualizations, data storytelling. So we'll work on your data scientist portfolio, and to give you a quick introduction, how do you understand the job market? How do you interpret different JDs, the job description in Malaysian market? And module 6, big data landscape. So before you graduate, we give you a broad overview of Hadoop. What is Hadoop? What is Hadoop ecosystem? What are Spark, Kafka, Flume? What are the key components in big data? And then how do you move on as a data scientist and with the knowledge of big data? You don't have to handle big data infrastructures. Like, you don't really need to know Hadoop, but it's good to know. So we'll teach you those things. And data science project in productions and capstone project. Capstone project is an interesting one because not only I want to show you how we do things. This data set you can find online, but I show you the right methods, the proper way of how data scientists do in their day job. Capstone project is you bring your own data set. We'll work with you together to make sure that your data set, and you know how to analyze your data set. So a lot of my previous students, they are from startups, they're from digital marketing, they are from medical, and they're from logistics also. Yeah, they bring their own data set and work with myself and a mentor and to solve their data science problem for their own job. So long story short, we cover 3 things during the class. Okay, we have theory, right? Everybody teach theory, but we also teach you how to implement and also put that into real world application. All right. So yes, this is a professional certification program, so it has to cover this thing. And we are not using Titanic data set in the class. We're using real data sets from HR, finance, real estate, e-commerce, social media, and digital marketing as well. Right. As this is a professional certification program, so you're expected to take exam, but this exam is not to test your memorizing skills. Yeah, it's not to test you how to write code. You need to totally understand the applications of an algorithm. Okay, and then once you understand them and you know how to apply them, you'll be fine. You'll be able to pass the exam. Yeah, you don't have to hard code or memorize anything. Yeah. And upon completion and you have passed your test, you will get a certificate of achievement. So this will help you to get jobs and to proceed in your career. Okay. So to recap, what's in the programs? You get 4 days of trainings, more than 32 hours with me, and you got 8 hours of access anytime online trainings videos. And you have course materials, those PDFs, those slides, those notes will be all given to you, and source code as well. So those source code you can take home and use it with your own data set straight away, with a little bit of customization. I will teach you how to customize them and tweak those numbers and parameters. And then you also cover the exam fee of 500 ringgit. So total value of this program is 8,841 ringgit already, right? So this program is not for you if you are somebody who is not committed. And if you give up halfway easily, you are expecting magic pill with immediate results, then this program probably not suitable for you. Yeah, but because it's impossible to become really good in data science without putting in time and energy. There are a lot of courses out there to teach you, like, become a data scientist, become a certified data scientist in 5 days. This is not those type of courses. This is not awareness course. It's a lot of hands-on, a lot of theory knowledge, impartial. So I'm imparting the skills to you. I'm coaching you and mentoring you. So you have questions, you ask, and then we answer you, because our trainers, myself and the mentors, we are in the industry. Yeah, we are not those people who can just come here to read slides to you. Okay, that is not that type of course. It's a long-term thing. It's a program, certification program to get you on the right track of data science, and that's how we fast track you. Yeah, what we want to do is to transfer as much knowledge as I can to you and guide you through the right way. So we provide the mentorship and support along the way so that you can avoid wasting time and money and go a long way in your data science career. Okay, this program is good, especially for those you want to become a data scientist. All right, you are already in a data-related job like business analyst, data analyst. This program is for you. And for those who are looking to switch to a data-related career and who wants to future-proof your career, this course is also for you. And if you crunch, analyze numbers in your day job like Ruben, digital marketers, data analysts, this is for you. Or you are somebody who are interested in learning data science, you know that data is going to be the next big thing. It's not going to be already. Data is the next big thing, right? Everything that you use, your phone, your watches, they're all generating data. Yeah. So it doesn't matter what background it is, you're welcome to join the class. Now, for those who are familiar with me, you know that during our webinars, we always give very good offer at the end. So the first thing that I'm going to offer to you is the access to our private support group. Okay, so to give you a scenario, how many times you look at a line of code, you struggle, right? Those who have taken online courses, how did this person come up with this line? And you don't understand it because it's not commented. They don't really teach you. They don't really tell you, hey, how come I write the code this way? You look at a piece of code that you wrote, you follow the online tutorial 100% already, step by step, but then you get the different results, or one of the package is not running. This is the part I'm with you. Okay, I got you. I'm a techie. I'm from a technical background. So the very first bonus is to get you to overcome this hurdle by providing access to a private support group. Now, you want to gain access to a group of mentors and alumni who are in data science and also from a wide range of different industries. So you are surrounded by like-minded people, right? It's not about who you are, but who you are with, who have learned successfully from my classes, and they're more than happy to support you to succeed. So you'll be part of the network. They are startup founders, they're digital marketers, and also they're entrepreneurs. So technical questions, like you have seen in the screenshot, right? Fikri, CJ, they always private message me for career advice and technical code questions. So whenever I'm available, I will answer, but usually the mentors answer before me. And also questions related to job seeking and interviews. They're able to help you. And we also have a Facebook group for sticky and threaded discussion. So sometimes if they are looking for immediate reply, you're stuck in your job or your exercise, you ask on Slack. Yeah, Slack is the platform that we use. Otherwise, you still have Facebook. Okay, so for example, one of our students is trying to use stop words for text mining and sentiment analysis. That's Sohail lah, alamak. That's Sohail. Okay, so yeah, the students, okay, the community members from the private group will answer him. Or you can look at Lysim's question. She's like, hey, how do I use TensorFlow deep learning to train a model to recognize physical objects? And then Edmund is one of the mentors you will meet during the program. He's currently a data scientist in Asia. Yeah, so not only you get your questions answered, but the community actually point you to the right resources. So we want you to learn and grow. Yeah, we learn and grow together through the discussion and active participations. Okay, so be engaged with the community. And yes, just to summarize, okay, everything that was coming from previously, and also a private support group. So the total value is over 11,000 ringgit already, just the value itself. And then let's look at the second bonus that I'm going to give you. Now, this part is good. A lot of the courses that you went, right, it's just courses. After 5 days, sayonara, bye bye, thank you, teacher, and you lost contact with them. Even you buy online courses, okay, they don't update it regularly, so that you lost touch with the industry stuff. Yeah, or if you have to buy those updates, you have to pay for the updates. Okay, I got you. This is what the second bonus is for. The second bonus you will get is a lifetime warranty. I've discussed with Ruben the other day. We're probably not going to do this for too long, yeah. But definitely, if you sign up tonight, you are going to get all the online videos, not just for 1 year, not just for 2 years, but it's for a lifetime. So any subsequent updates that we make for upcoming classes, you'll receive the benefits at no cost. Okay, at the moment, yeah, we are also giving you the lifetime access to the private group and also the Facebook group, but it won't be too long lah, yeah. Okay, but if you sign up this round, you still get those benefits. Okay, so total benefit of over 17,000 ringgit already. Yeah, lifetime warranty, private support groups, exam, PDF, source code, everything is given. All the templates are given to you. Okay, so if you survey a little bit, yeah, for those who are actively looking for a course to sign up, you'll know that my public courses are around 6 to 7,000 mark. Yeah, HRDF courses, especially those outside training providers. And if you want something that is more private, more in-house, or more custom-made, tailor-made with my consultancy services, anything, yeah, 12,000 per person, yeah, anytime. Okay, so tonight we're going to open up the public registration for our upcoming Data Science 360 certification program. With I don't think there are 8 seats. I think probably 5 or 6 seats left only. So standard registration, if you're interested to go for the class, we still have a couple seats left. 3,599 per person. 8 hours online training libraries, 4 hours physical classes, etc. Or if you are someone who are looking for some serious kind of coaching and mentorship, I also have 2 spots left for the personal mentoring. So you can join me you'll get 2 months of personal consulting with me. So I'll customize your learning plan with you. I will have 2 times weekly coaching call, 30 minutes with you also. Yep. Okay, just 2 spots for that. So to sum things up, Data Science 360 professional certificate, you get certificate, you get lifetime warranty, you get support group, you got everything. And the most important thing is I'll be there with you for the 4 days program. Yeah, so you get total more than 48 hours of trainings with me. This is like a university subject already. So people always ask me like, Dr. Lau, you sure 4 days can finish? I said, you sure? 48 hours, is a lot. Yeah, we pack a lot of values and content in there. Okay, so before we go into further Q&A sessions, I'll pass the mic to Ruben. I think he has more good news for you. Yeah, he has one more good news for you. Over to you, Ruben.
Okay, I'm just going to turn on my my webcam here. So okay, guys. So as Dr. Lau has mentioned, we really appreciate people who stay on to the webinar till the end. So what we're going to do, and what we normally do, is instead of 3,599. By the way, let me just correct you, Dr. Lau. We don't have 6 more seats. We only have 5 more in Data Science 360 this intake. Okay. So instead of 3,599, we are giving you tonight a price of 3,099. That's 3,099. Sorry. All right. And I'm going to give you the link to the landing page as well, so you can look at the page for more information there. I'm going to paste it down right here, so you can look at Data Science 360 and see what's included, what's inside, read everything about it. But if you want to get a price for 3099, this is a special link. All right, I'm going to click on and type this down. This is a special link to get the course and also lifetime membership for only 3099, and it's just for 5 people because you only have that left in the class, and it's only for tonight. Okay, so I'm going to paste this out on the screen so you can see it, and I'm going to publish it right here. Okay. Okay, so let us know if you have questions to the course. We would love to help you out with any questions you may have. You know, if you have doubts about it, you don't think it works and all that, let us know, and I'll be happy, and Dr. Lau will be happy to actually answer you in that. All right. Zimzan, I hope I got your name right. Yes, there will be another round in the future, but we do not guarantee the same price. Okay. So in fact, the last time we did Data Science 360, the price was actually lower, if any of you remembered. Right now, the price has already increased a little bit. And again, we don't want to disappoint you, so we don't guarantee the same price for the next intake. So what I would recommend you to is to actually take the course right now, right? Take advantage of the price. So what's going to happen is once you take advantage of this price right now, as a student, if you can't make it to 1 or 2 of the physical classes, you can always come back to the next intake, to the physical class in the next intake for absolutely no charge at all, right? So as a student, you get a kind of, what's that word? You get a kind of incentives or advantage, right? You can come back to any physical, yeah, you get a benefit where you get to come back to any physical classes at no charge, all right? So what you want to do now is to take advantage of the price we are giving out today, okay? All right, so while you're going through the pages, keep your questions coming. I'm just going to go back to some of the questions that were asked earlier and get Dr. Lau to answer them. Okay, so keep your questions coming. I'll get back to them. And okay, Dr. Lau, maybe you want to answer Zulfazli's question first before we go on to the next questions.
Sure. So Zufari, what is the content of the physical class? Okay, so basically in the physical class you have 4 days. The last day will be focusing on helping you to get your data science portfolio, your projects there, and the capstone project that I mentioned. So you're welcome to bring your own data set, whether it's from your company, your current jobs, or a data set you're interested to solve a particular problems, and then you bring it here. We work on it together with myself and Edmund, the other mentor. Now, the other 3 days, we'll basically go through the content from module 1 to module 6. So first day, we'll go through setup of your workspace, and then ETL processes, cleaning your data set using HR data set. And then day 2, day 3, we'll focus on the other subjects. So MongoDB, and unstructured data, sentiment analysis, and also some of the visualization tools that will be covered. The same thing, like basically your online videos. So the online videos helps you to strengthen it. So a lot of time, like one of the students, a couple of students actually mentioned that they love to ask questions. Yeah, they have questions, but they are shy, and sometimes they go back, they watch the video a few times, they get a better understanding. So you take the videos as something that help you to train yourself further, and then to help you to understand the content better. Yeah, so the physical classes will cover those key topics that I mentioned, and especially the last day will be the exam, and then to help you to work on your own projects. Okay, does that answer your question? Thanks, Zufali.
Okay, while you guys keep your answers coming in, we're going to go to some questions that were asked earlier. Okay, so this is the Q&A session. Go ahead and let loose with all your questions, and you'll get them answered. All right, so I'm going to go back to the very beginning. Okay, I forgot who asked this question, but I'm going to type this down here so you can see it. So the question is, based on my reading, a data scientist spend 80% of their time doing data cleaning. Can you elaborate more on data cleaning? Maybe there's a short one, Dr. Lau.
Yes, short answer, yes. But Ruben, you know me. I always go very elaborative when it comes to answer questions. Ruben always say that to me. So yes, 80% of our time we're spending on cleaning up the data because the rest of the task does not require a lot of time. Majority of the time is spent on cleaning data because garbage in, garbage out. So if you don't have a very clean data set, you put into the model will still run, but the result is bad. Usually there's nothing much you can do with your model. You only have to understand your data very well. You clean them up, you slice them well, and then you can put it into the model and expect the model to behave, to perform consistently. Those models that we use in data scientists day-to-day job, the models we have been using it for many years. Yeah, so we have been using it since the time of data mining, data analysis. So not much innovations, or I wouldn't recommend anyone to tweak those models unless there are some groundbreaking techniques. Otherwise, even like neural networks or deep learning, that sort of stuff, right? They're all still based on traditional or very fundamentals mathematics model, and we make adjustment because of the large amount of data that we are able to obtain now, and then train the models to make it smarter.
Okay, all right. Elaborate answers as usual, Dr. Lau. Yes, Danny, you would need to bring a laptop for this. Yeah, so all our students actually bring laptops to the class so they can practice on their laptop, get things installed on the laptop to do this. But before the physical class, most of the classes are done online. All right. So once you join Data Science 360, you would have access to all our online classes, all the materials, all the documents, everything, all the practice materials, and you also have access to the Slack group that we have. So that's where you can ask questions, you can ask all sorts of things. All right. And we are giving this to you at a lifetime membership to you. All right.
Yeah,
Now,
as soon as you
because
sign out, you get access to the class already immediately. Yeah.
yeah, so imagine that you can join. If you join today, you can log in tonight itself and start learning straight away. Start talking to all your classmates inside the Slack group, and also to all of us. But in the recent weeks and months, the size of all the memberships in Slack has become so big, right? We are growing our community, and that's where we decided to put in the future, in very near future, put in sort of a monthly membership fee to maintain. So we are able to actually maintain the communications going on that group, all right? But right now, we are giving you an opportunity to jump into this course and get a lifetime membership, all right? So I would advise you to take advantage of that. Okay, Shafiq, can I book my spot without paying full price first? Okay, I love to extend that kind of offer to you, but I like to be fair to everyone else here as well, all right? So unfortunately, we don't have booking like that. But yeah, if you really need help, let me know. Again, I'll be honest with you, we don't do things like that because we want to be fair for everyone here and also outside. Okay. Let's see. My laptop just lost out. All right. I hope you get your computers fixed up or buy a new one. We recently had some discussion in the groups about laptops as well. I think Dr. Lau, you recommended us to buy an Apple laptop, is it?
I think most of them will hate me if I tell them to get a Mac. But yeah. So if your budget allows, I would say get a Mac because it's quite robust and then good CP value. It lasts you for a long while. Otherwise, a simple laptop, i5 processor with at least 16 gig of RAM, 8 to 16 gig, yeah, because we're not going to run any super intensive kind of computation and stuff, but yeah, you'll get a smoother experience. So we'll install some of the standard tools. Most of the tools will be non-graphical user based. Yes, it's either like the web based that you have seen, and then you just needed to watch videos and run some of the codes.
Right. Okay, so guys, join the course right now for only 3099. Once we have 5 students joining us, or once the night is end, once we end the webinar, we'll close down the price. Okay. we're closing the price and you would have to join at its normal price. Okay, so let's go into the next other questions that we have. Again, if you have questions again, anything at all, just type it down in the chat section and we'll be back to actually answer you. Okay, so I'm going to type this down. This is a question that we answered in our Data Crunch YouTube series. So what is the difference between data science and big data analytics?
Okay, good questions. Data science is usually the field of study, and it comprises of a lot of data science itself is a concept. Okay, although it's classified as a field of study, but it's not really a data science like biological science or physics, that type of science. So you need to have a bit of mathematics background, you need to have a bit of coding background, you need to have a business acumen to understand the business well, and a bit of hacker mindset. So that's what data scientists are for. And there are two types of data scientists. You can be a type data scientist who are quite analytical, so like Ruben. Okay, or you can be a B type data scientist, which is like myself, a more builder type. So I always like to build models, I always like to build data science application to see things work. Then only I make changes and tweak it, because I know how to write programs. So there are two types of data scientists there. And big data analytics, like I said, right? Big data is a term that used to describe things that cannot be processed with the current technologies and software. So have to give it a name, just call it big data lah. Okay, just give it a name to call it big data. That's how it got its name. And then big data analytics itself is still based on those analytics that you get from data science. If you're talking about big data analytics itself, like BDA got nothing special one. Unless you're talking about neural network, deep learning, and then the couple of big data, yes, then that it is. Otherwise, BDA itself is just a type of analytics using big data. Yeah, the techniques behind the is the same, except the infrastructure. They're running on Hadoop, they're using Spark, they're using Kafka, but the techniques and the codes that you run, they're still based on the same thing. It's still Python or R. Yeah.
Okay, and thanks for the answer, Dr. Lau. So just to remind you guys again, the course would start right away. So once you join the course, you'll be able to log in tonight itself, join the community tonight itself, and start immediately. And the physical class will actually happen on the 25th and 26th August this month. All right. Okay, so yeah, Jonathan. So me and Dr. Lau actually we have the same model for our MacBook Pros. We carry around a 15-inch MacBook Pro, and that has been fine. In fact, I carry it around in a bag looking like this. I'll show you right here. All right, and come on, we are all men. We can carry things like that, no problem at all. Okay, so it's a good investment. I think personally, if you ask me, the MacBook Pro 15-inch is a good investment. The baseline is good investment. No doubts about that. All right. Anyway, that's a sidetrack. Okay. Should we answer Fadli's question on Python or R, which is more feasible for data science? That's a good question. Dr. Lau?
Yeah, good question. So Ruben probably hear me answer this question multiple times, but okay. Every time I try to give you some new perspective. So Python is a language itself that's designed by computer scientists, and R is a language that's designed by academicians, especially statisticians. So if you're coming from a non-technical background, okay, you're coming as a statistician or academician, you will find R a bit user-friendly to you, as in you find it more familiar. You're like, oh, okay, this is how they frame things, this is how they write things, the syntax. Yeah. But if you're coming from a computer science or you're coming from a programming background, you'll find that Python actually is more intuitive and easier to understand, because the way, again, is the syntax. So between Python and R, the user base is very hard to tell, but Python itself as a language is number 2 or 3 leading language in the world. So it's after Java, JavaScript, and then Python. Yes, it's around there. It's definitely in the top 3 or top 5 category, because Python allow you to do a lot more. You can use Python to build websites, build secure website using Django and Flask, user authentication, scripting, scraping websites. A lot of things you can be done with Python. But when you use R, then it's a different story, because there are limitations that you can do with R. So if you want to build website, you probably need Shiny, and then Shiny is not as intuitive when it comes to compare with Python, for example. So these are some of the considerations, or I wouldn't say pros and cons. In terms of data science, their packages are about the same. Yeah, so most of the packages you have in Python, you have it in R. Statistical packages, deep learning packages, machine learning packages, also the visualization packages. Yeah, they're all there.
Okay. Using big MSI laptop. Okay, I believe the MSI gaming laptops are much heavier than MacBooks. Yeah, that's a given.
Coincidentally, Ruben used to have one also.
Yeah, and it was a bad experience, super bad experience. So guys, if you have the budget, I would advise you to go for Apple. I mean, put all biases aside, I do think the MacBook Pros are much more stable. It gives you less trouble, less headaches. Danny, what IDE is preferred for Python? I personally like Spider.
Yeah, Spider is not too bad. If you're writing Python, I will suggest using the one from JetBrains, PyCharm. Yeah, PyCharm is good if you can pay a little bit and get the license. And if you need IDE, usually we don't need IDE when it comes to data science, except when we go for production. So we need it for debugging. Yes, then IDE will be good. PyCharm, I recommend PyCharm. Otherwise, if you are looking for free options, Visual Studio Code is not too bad. And also Jupyter Notebook. Jupyter Notebook is good when you want to write a lot of side notes, you want to go for presentations, and you want to run things in block and chunk. Yeah, it is good.
Okay, I'm going to go back to the earlier questions while you guys keep your questions coming in. But before that, in case you missed out the link earlier, I've put it up on the sticky chat here to get your special prize. Also, I'm going to paste it down here one more time. So in case you missed it earlier, here's the link for your special link. Again, at the end of the day, we would actually close off this link, and once we get 5 students inside, we actually close off the prize, okay? To make it fair for the others who are not in this webinar today. Okay, so I'm going to go for the next question that we have here. Okay, this might be, not sure if I understand this. What is suitable? Let me try to interpret. What is suitable for machine learning technology for unstructured data, like image?
Depending on your use case, it's not really like the particular ML or machine learning technique. So say for example, if you are trying to classify images, then you can still extract the features or the data that you extract from those unstructured data are more important. Let's say if you are doing music recommendations, you can still use the standard recommendation algorithms, but you put it into audio format, you use the sound wave data. If you're doing recipe recommendation, you can do the same thing too, right? Otherwise, if you want to group user behavior based on their preference on e-commerce, you can use any of the clustering methods like k-means or hierarchical clustering. You can achieve the same thing too. So I don't think it's up to any particular machine learning algorithms or technique. Yeah, you can still use the same one, but you have to find a way to extract the features from the unstructured data that you are working with.
Okay, right. Thanks for the answer, Dr. Long. Oh, I see someone has signed up for the course, so thank you for that. That means we only have 4 seats left right now, guys. Okay, 4 seats left right now. So once these 4 seats are gone, we will actually take off the price, and we'll actually go back to focusing on creating a good experience in the course for our students. Okay. All right. So I'm going to go to the next question that we have here. how is predictive analysis different from statistical?
Okay, statistics is the part where you analyze the data that you already have. Basically, no discrimination, but they are working on the high side. So you're statistically analyzing your data. So you try to look at different things like average, your mean and max, your percentiles, and then from there you do your reporting. Okay, and if you take that a bit further, then most of the time we'll use it for business intelligence as well. So it's like a health check report. Yeah. Imagine somebody go for health check. You're going to get your blood pressures, your blood sugars, your cholesterol level, your body fat. Those are like statistics. Yeah, a good statistics about your body. So if you're talking about a company or a data set, yes, you get good statistics about the data set. But when it comes to predicting your future, then there's nothing we can do. Right? You can't know the future, but predictive analytics is sort of like looking at your historical data. We are going to predict. So let's say we look at your patient history. Okay, you have been smoking 3 packets of cigarettes per day. We can predict that this guy is going to get lung cancer in the next 12 or 24 months, for example. So those are predictive analytics. So predictive analytics, to me, I would say it's like a tool to help you to take a sneak peek into the future with a certain level of confidence, which is the performance of your model.
Okay, very elaborate answer again. Let's see, let me just type out this one here and check out on the other questions that we have. Just give me a moment here. Let's see. Okay, I think the other questions are more technical. Let me just take one random one out here. Okay, I don't know if you answered this earlier, Dr. Lau, but I'm going to type it down here. So what is a good way to display the data based on hours per month? For example, 500 hours utilized over 720 hours.
I hope the one who asked the question still here. So, for example, you are looking at 500 hours utilized over 720 hours. Is that a time series? So, if it's a time series, then you can look at. If it's a continuous data, usually we use line chart. So line chart can show you the trend, like for every 720 hours. How do you use that? But if you want to count them individually by per hour block, and then you can further slice them into, let's say, for the past 7 days or the past 24 hours or past 48 hours, then you can use a bar chart. Yeah, that's fine too, depending on how you're counting the data. So discrete data, non-continuous data, you can use bar. Continuous data, then you can use a line chart to show the trends. Iqbal, what algorithm should we learn to build a recommendation system? So you can use clustering. Clustering is what we use to build a recommendation system. We can do that in Python too. And if you want to go deep into recommender system, there are a few different types. So depending on is a content based or is it like a filtering based, then you can do things like association rule mining, ARM. This is one of the techniques that I teach in the class as well. So you look at items based on their similarity. So for example, people who buy bread, they usually buy milk. People who buy milk, they usually buy eggs. So people who buy bread and who buy milk, usually they will buy eggs or butter as well. So from there, we calculate the number of transactions they have similar behavior. Okay, they always get bought together. And then from there, we can calculate the confidence level and the support level to build a recommendation system. So next time when a new customer that comes in, they buy bread, and then you can recommend them, hey, you purchase bread, and 78% of the population who purchase bread actually purchase egg. Would you like to purchase egg as well? And chances are they are going to buy. So same thing, people who who bought a book, let's say from this particular author, and they will most likely would like and the book from another author, but along the same categories. And that's how I did my project in Hero Boyfriend as well. That's when I run the startup. So people who are who are more health conscious, then we can recommend them things like hot yogas, healthy food options, for example. So yeah, association rule mining, ARM.
Okay. Okay, let's see.
Okay, so Jimsen, you are counting the data by month first to make it easy. Yeah, so if it's counting by month, then you can easily use bar chart. Yeah, unless you have specific use case lah. No problem, Iqbal.
Okay. I'm gonna paste this one down. This was asked by Jason earlier. So after I've done some analysis using the tools you've mentioned, how do I add it to a website? Do I download via PNG and post it?
Okay, good question. So if you have done using the analysis or using the tools I've mentioned, right? Let's say you have done it using Python and using Jupyter Notebook. So you can turn those code into a production code by running it as a web server, okay, or as a web service. Now from the web service, you can expose the data as JSON format. Once you pick up those data as a JSON format, name after you, JSON, all right, JSON, name JSON format, then you can pull the data and draw it using HTML, CSS, and some JavaScript library, for example, HighChart. Yeah, you can then turn those data into visualization there. Yeah, not necessary. You can still use the matplotlib, but those will not be ideal because they are not interactive. But if you use like HighChart or Plotly, that sort of third-party framework, charting framework, then you can draw much sexy and visual appealing charts.
That's interesting. All right, guys. So if you have more questions, go ahead and type it down in the chat section. We'll still be here for a while to actually answer more questions and to help you out. In questions you have related to data science, analytics, and also predictive analytics. All right. So let us know in the chat section below, on the right, not below, on the right, and we will be happy to answer you while we are still here online. Okay. Now, again, I just want to remind you that we are going to close the price at the end of the webinar. Okay. Again, if you like to join the course, let us know. And I would advise you to take advantage of the low price that we're giving right now. Again, we run Data Science 360 about 3 to 4 times in a year. All right. But as a student, you always get to go back to any physical class that we hold in any of those intakes. All right, to reinforce your learning and to make sure you get everything right. Okay, so that's what we extend, or that's the benefit that we give to our students, and we want our students to actually see success for that. Okay, so let us know. We'll be happy to help. And yeah, your link is up there, so go and use it if you see it. If you cannot see it, you cannot find it anywhere, let me know. I'll be able to help you. Okay, and if you want to look at the course outline, the structure, the reference to all, you can actually look at the site. Sorry, I was reading the comment there. You can look at the site. Yeah, I think you have all the links. Okay. So I'm going to go to the questions that we have. I think we only have one more question that I've written down. So let me see what question is this. All right.
Jim, you want to pitch to Alan or TJ? All right, Alan. Okay. Send him my regards. Yeah. Yeah. Okay. Alan is a close friend. He CEO of Gokra, ex magicians. Yeah.
Right.
Okay. Ruben, go ahead. Yeah. Next question.
Also, by the way, the course is we are HRDF certified. So what happens is if you're coming from a company, your company can actually get what do you call that? Reimburse the course fees from HRDF. All right, just let you know that. Okay, so the question that we have here, I think it's the same question that was asked earlier. I'm going to paste this down just for the sake of pasting it. So I think this was the same question that Jason asked.
Yep. So how do we showcase the results, output the model prediction, website, customized apps? So similar thing. That's why I would say Python has a slight advantage because you can easily, relatively easier to export it into API and then showcase the data. Otherwise, there's another way of doing it is you can write that back into a database, and then for the third party software like or your who is that? Your mobile apps. Yeah, so mobile apps can also retrieve those data from the database, and then you present it. In a way that visualization is always your last mile, your last mile delivery, so that you have to use that to present to your end user. Your end users, your target audience, they won't appreciate numbers. To them, numbers are numbers. They are hardcore facts. So only if you're able to present them in a visualization format and able to use that to tell a story, then only they are able to appreciate. And ideally you want them to, based on your story, to take some actions. Whether you want them to do something or not to do something is all up to you and your story.
Okay, and looking at my list, yeah, I think that sums up the questions that were asked earlier. Now, guys, if you have more questions, go ahead and ask in the chat section here. Anything at all, we'll be happy to help you with those questions. Probably we can hang out here for a few more minutes just to get some questions coming in and to answer them. Dr. Lau, anything else you'd like to actually share or to sum up from what you're sharing today?
Sure. If there's no more questions, thank you very much, everyone, for being here. Now, predictive analytics is a very interesting area, and I would say that usually it's the first step people do or people learn before they actually enter the fantasy world of artificial intelligence. And combining with things like unstructured data and clusterings, it will give you a very good opportunities to explore the data and understand things much better. Yeah, I think that's a good way that I want to summarize predictive analytics.
Okay. Okay, so guys, again, I'm leaving you guys with the link here. Let me just type this down one more time. Last time here before we go off for today. Going to wait for a few more seconds to see if there's any more questions. If not, I'll leave you with this link. Again, once we close the webinar, the price will be gone. We will leave the price probably up to midnight today. And once after midnight, we'll just close down the price and you would have to join at its normal price after that. Okay, so I'm just going to wait here for a few more seconds to see if there's any more responses or any more questions from you guys. So a few seconds from now. Okay, so we have one from Jason Gan. Dr. Lau, I'd like you to jump on that.
Oh, okay. Hi, Jason. What is NLP built upon, or what algorithm generally or technique used? Actually, NLP, people try to make it sound like very magical, but behind NLP is actually statistics. NLP is very statistical. So what we do, give you an example. Let's say you have a keyword, right? You enter a keyword, say digital marketing in Malaysia. Right. So digital marketing in Malaysia, we want to use these short words. What Google has done very well and caused them to become a billion company or unicorn is because with very short text, they can use it to find very long document and that's relevant. So that's where NLP things comes into place. NLP has a couple of different components. The first thing is statistics, that I mentioned, to count the number of words, how many words are there in the articles. And when article A and article B has similar numbers of words and distribution, they are considered similar. And we use very mathematical trigonometry model called cosine similarity just to measure their similarity. So that's number one. Number two, when it comes to things like topic detections, document classification, sentiment analysis, they are all using standard machine learning model. So if I want to classify a document into their respective categories, I can use decision tree that I showed you before. That's perfectly fine. And if I want to group topics together, I can use the same thing that we do it in e-commerce. We can use clustering to do that together, to do that as well. And sentiment analysis is just by counting numbers. So for example, you have one article that has happy, delightful, awesome, and these are positive sentiments words, and we can simply add up the lexicons, the value of those lexicons, and judge that this is a positive article, a positive tweet, a positive review. Now, if there's another articles or there's another review on your product to say that I hate this product, it does not work, and things are these are the indicators or the lexicons that's showing you that they are negative words, so you can conclude that this is a negative tweet. And if there is a line with a sentence or the review with product works, thanks, they are very normal, standard, a very bland one, you can consider or conclude that this review is neutral. So by giving you all these examples, right, it's actually telling you that yeah, they're just normal. They're just normal statistical information. And comparing to other unstructured data such as images and audio, texts are relatively simple because it's only single dimension. Although the dimension space are very high, you have a lot of different words, but you don't have multiple dimension. For example, an image can have RGB, three different colors in single pixel. If you're talking about videos, you have time dimension, you have image motion dimension, you have audio dimension. So those makes things even harder to process. Yeah. So I hope you get an idea of what is that.
Okay, and we probably answer one last question from Zinzan before we go off for today, Dr. Lau.
Sure. Can I briefly explain what is sentiment analysis? Sentiment analysis is a technique in correlate to Jason's question. It's a technique that we use in natural language processing to identify the sentiment or emotion, orientation, and polarity for a particular piece of text, TXT, textual information. So let's say somebody wrote a review about your product or your service, then you'll be looking at it. One or two tweets you can handle, 10, 20 tweets or 50 tweets, you can still hire somebody to handle. But if you're talking about 10,000 tweets per second, you are not only looking at yourself, you're also looking at your competitor. Samsung is spying Apple all the time to look at what people talk about them on social media, on Facebook, on Twitter, on Amazon. What are the good things that people talk about Samsung? What are the bad things people talk about Samsung? So you have to do this sort of competitive intelligence thing and using scripts, right? And sentiment analysis is one of the tools that can help to do that. And for politicians, everybody knows the drill. Cambridge Analytica, they listen to all the different types of social media to talk about, to use sentiment analytics to identify topics that get people, that trigger their emotions, right? Politicians, they know that anything that trigger your emotions would be a very good, not a good word to say that, but will be a very good weapon that they can exploit on. So if they know that, okay, you're very upset about education issue in particular area, so they will tell the politician, when you go for a rally at that state or that daerah, yeah, use this topic to stir up. And if you know that they hate a particular politicians because of something that they say, a negative sentiments, then they can use that as a weapon as well. Yeah, so a lot of things that can be done with sentiment analytics, but long story short, is a technique to help you to identify sentiments, opinions, those polarity towards text information.
Right, that's very helpful, and I think sentiment analysis is something really, really interesting. Okay, so thank you guys for all your questions and your participant up to 10:15 right now, 10:12 actually. Right, so again, thanks again for coming for the webinar. I hope you all learned something. Now, before I go off, I just want to put down our emails again. Now, some of you may have some questions or something that you want to ask us in private. No problem at all. We read every email. We respond to every email. We'll make do with them. We always respond to all the emails that we get. So if you have any questions that you'd like to ask us, any personal one at all, you can always drop us an email at ruben@thelead.io or Dr. Lau at the.io. Okay. Now the course that we extended to you tonight is Data Science 360, which you can visit here. And as again, I've already pasted up your special link on the above, which we will close at the end of today. All right. So again, in closing up the webinar, I again want to say thanks for joining us up to now. We hope you enjoy the content as much as we enjoyed creating it for you. Dr. Lau, anything you'd like to say before we close off the webinar?
I'm really impressed and excited by the level of energy. And yep, thanks very much. And Ruben will send the slides and the source code that I use here. So anything that you don't understand, so yeah, you have questions, just ask us. And Ruben, you want to advertise a little bit for our data crunch as well?
Okay, so guys, we actually have a series on YouTube that we newly just launched, and that series is called Data Crunch. All right, I'll spell it out for you here in the chat here. Let me just type it down for you. It's called Data Crunch, and if you were to just go and Google it, Data Crunch, Dr. Lau or something like that, you'll probably find our video up there. Okay, now we're just starting out on this series of Data Crunch series where we talk about data, data science, data analytics, AI, and also machine learning. So if you Google Data Crunch Dr. Lau, you'll probably see it online on YouTube. Okay, so go and watch it. I hope you get more info and more information out from those videos. And again, the best thing is we hope to see you in the courses, so we can work with you and help you get to the goal that you wanted to initially when you joined this webinar. And as always, I thank you again for joining us in this webinar and hope to see you soon. All right, so...
All right, good night. Thank you very much.
All right, bye-bye, guys. See you again in the next webinar and see you in the courses if you're coming. Okay, bye-bye.
Bye.